All right, for those of you who came to class, I do again apologize for the technology issues that we were having. I hopefully will get this up in very short order. I have set a cap of 15 minutes per video, so if we go longer than that, I will have more than one video up. All right, so this has to do with roots. And roots are the undoing of exponents. All right, they're the undoing of exponents, sort of like subtraction, undoes addition, right? So this is the same kind of concept where one undoes the other. So we use what's called a radical, and that's what this is. And when we have no number in front of it, we call that a square root. When we have a number in front here, we talk about it being that number root. So it's possible to have a cube root and a fourth root and fifth root and so on. You're going to use n. I'm going to say n just for the generic number. And that means we're having a nth root. All right, so in practical terms, what does that say to us? Well, if we say that we have, for example, we have a 4 squared, right? That's the same as a 4 times 4. And that means it's going to be a 16, right? Everyone's real clear on that point. So here I've got my symbol that means therefore. All right, so 4 squared equals 16. Therefore, the square root of 16 is going to equal, and I'm going to pull this apart into its basic forms, okay? So I'm going to start with a, splitting it apart to be a 4 and a 4. So this is a 4 times 4. So I have a square of 4s underneath the square root, right? Which means that when I undo them, I'm going to wind up having a 4. All right? If this, we can take this to extend beyond just a square root. I can say I have an 8 under a cube root. Here's another example. So if I have a cube root, let's got my little 3 in front, and I have an 8 underneath. Well, let's factor this down to its primes. So I can say, again, I have a cube root. It's real easy. I tend to do it a lot. So it's real easy to drop this number in front, which is going to make a huge difference. We want to make sure that we are not dropping that. But I'm going to pull this apart to be a 2 times a 2 times a 2. Right? And here I have the cube root of 2 cubed, which means that the cube root and the cube, let me actually just cross those out using a different color. So the cube root and the cube undo each other, so what I'm left with is the 2. All right, so that is my answer. Now, a couple things I want to be super clear on. We've talked a little bit about what happens when we have a a negative exponent. So if I were to say 4 to the negative 2, right, we understand that to be the same thing as 1 over 4 squared, right? Because this is saying the negative says it's not living in the right part of the fraction. Okay, so that moves it down here. So this becomes 1 over 16. That is not the same thing. Okay, so it is not the same thing as 4 squared under the square root, which is just going to be a 4. All right, so this and this are not the same. They're not at all the same. So just as a rule of thumb, right, as a way of keeping track of things, if I were to say a to the nth power is not the same, and this is a generic base, right, and I'm going to have a generic negative n here. Those are not the same thing. And I'm actually going to put this as to be a 1 over n, because if you think about, right, if we think about our circumstance around the exponents, right, if I say I have a 4 squared and then I have the square root, right, I'm going to ultimately at the end I have just a plain old 4, which is a 4 to the 1, right? So our goal here is to get to the 4 to the 1 because I'm taking the square root of a square. So this would be the same as saying 4 squared raised to the 1/2 power, because 4 times raised to this 2 multiplied by 1/2 gets us to that 4 to the 1st. All right? And this is not an accident, right? This is not an accident. The fact that we're using for a square root, right? We are using a 1 over that number. So let me give another example. If I go back to my cube root for 8, right? I'm going to pull this apart and I'm going to say I have the cube root of 2 times 2 times 2, which is the same as a cube root of 2 cubed, which is the same as my 2 cubed raised to the 1/3 power, right? So this is the power of a power. Remember that exponent rule. That actually comes into play here, and sometimes it's easier to think about it like that. So here I'm going to wind up with a 2 raised to the 3 times 1/3, which gets us 2 to the 1st, which we just talked about being just a plain old 2. So hopefully this is making a bit of sense. I do want to point out that we can have more than just our square root. That one, if we don't have a number out front, it's understood to be a square root, or a cube root, which we understand is 3 times. It can be whatever number we want. All right. So if I were to say I want the 4th root of 81, right? I have the 4th root of 81. I want to break this down into its primes as much as possible so I can see what's going on and see if we can pull anything apart and just turn it into a regular plain old number. So here I could say 3 times 3 times 3 times 3, because 9 times 9 gets me my 81, and 9 breaks down to 3 times 3. All right, so now I've got this where I say my 4th root is going to be a 3 to the 4th, which is the same as 3 to the 4th raised to the 1/4 power, which means I have a 3 to the 1. Now, so far this is super easy, right? Everybody's like, okay, what's the big deal? Well, it sometimes sometimes, in fact, most of the time, do not have a perfect number. I've been using just like perfect cubes or perfect squares, right? So that it turns out nicely for us. But what happens if I were to say, I want the square root of 8, and I want the exact number, all right? So I'm going to say exact number. I have to have the exact number on this. So what I'm going to do is I'm going to pull this 8 apart, and I'm going to take it down to its primes. So I've got a 2 times a 2 times a 2, right? So now I've got 3 2's under here, and I am looking for a square root, right? So I can turn these 2 into a square, right? So let me go ahead and do that. And this seems like a lot of extra work, and I'm not expecting you to do that unless it helps you make sense of it. I'm just trying to show you the step-by-step what all is happening here. So I'm going to have a 2 squared, right? That's this one here. That's this piece. And then I've still got the times 2. I can't just drop that out of there. That's still got to be there. Which means that this piece and this piece are going to cancel each other out. And I'm going to be left with 2 times the square root of 2. And that is the exact answer. I know people don't like seeing that square root in there. It's like, but it needs to be a number. Well, unless it's a perfect square or a perfect, whatever power, you're going to have some kind of like weirdness at the end. And it's okay. That is actually what it looks like. I'm going to run to the end here of my time. I want to make sure that I get this posted real quick. If you have questions, certainly let me know. I'm going to probably do another video showing some examples. Okay?